where to begin? It's questions like these that give math a bad name. I love the chain rule as much as the next guy, but let's be serious. This question is just cruel. Clearly, the author of this question had some serious childhood emotional trauma to deal with, because he gave his students a question like this. This question is just really, really, really messy. Dealing with all of those exponents and parentheses is going to get really old, really fast. Calculus is a daunting subject to begin with. For a lot of people, an introductory calculus course is the most difficult math they're ever going to see. Seeing a question like this on a test or on a homework assignment will only discourage these people from learning more about math. It's just too complicated. Math is about making the difficult look elegant, not making the difficult look difficult. Yes, this problem can be solved. It's not impossible. However, I think with an introductory calculus course, I would rather give a question with an easier computation because by doing so, the conceptual side of things can sink in more clearly. I think introductory calculus has such vast applications that to scare someone off by making questions like this, it's just wasteful. By making math learnable, we make it useful. Alright, you sticklers, I'm going to show you how to do this. Now, when I see the chain rule, what I think of Shrek. I think of Shrek, and I think of ogres, and I think of onions, donkey, and layers. So, if you notice, I have my parentheses color-coded. It'll help us in taking derivatives. Now, let's start with the green. We take the derivative of both sides. We take the derivative of the biggest function. So let's just pretend everything in here doesn't matter right now. So it's going to be the power rule. 5 comes down, 5 times 10, 50. Then this is going to go to a 4. So we're going to have 50 1 plus, got a lot of markers here, folks. Oh, enjoy the incubus in the background. Now, this is only going to be to the 4th. Now we use the chain rule. We have to multiply by the derivative of the function inside, which is going to be this red thing. Now, this is also included as part of the function, but we know that the derivative of a constant is 0, so the derivative of this is going to be 0. So now we just have to multiply by the derivative of everything inside the red parentheses, which is going to be times 3, power rule, 2 minus 6 plus 7x to the 4th. Now, since we brought this 3 down, this is going to become a 2 here. Very good. Now, we have to multiply by the derivative of the function inside here. Once again, the derivative of a constant is 0. But keep in mind this negative sign is going to turn this into negative. So we want to multiply by the derivative of the function in the blue parentheses. So times 9. Oops, don't forget the negative. 6 plus 7x to the 4th. Bring down the 9, this becomes an 8. Very good. Now all that's left is to multiply by the derivative of the function inside here. This is going to be 0. 4 times 7, 28, x to the 3rd. So times 28 x to the 3rd. Alright, now all we need to do is multiply out things that we can. I'm not going to multiply out these. I'm probably just going to multiply this, by this, by this, by this, and leave all those where they're at. Alright, 1 second. Alright, so I did out all the algebra, then I left all these nasty squares and 9th powers and 3rd powers and 4th powers by themselves. This is exactly the answer they have on the website. Take it all in. Don't you wish you guys did problems like this when you were in high school? This is just rough. But it's possible if we use our layers. However, just too hard of a question? Meh.